So we're going to continue on the lesson from 3.5. We talked yesterday about expansion of the multiplication of binomials. So these are the questions that we did here yesterday. Binomial times binomial. And we noticed that we got this trinomial each time we did that. Okay? And so we're going to focus on questions today where we have trinomials that can be factored. And I just want to go over one more thing here with you. So just as a review from yesterday. Let's say we have x plus 2 times x plus 5. And if we're multiplying those together, you should by now know that x times x is x squared. X times 5 is 5x. Of course, it's positive here, and these are all positive, so it's easy. Positive 2 times x is plus 2x. Positive 2 times positive 5 plus 10. We gather like terms, and we get x squared plus 7x plus 10. Okay? What I want to ask you and what I want to point out is that there are some definite similarities and there's some definite patterns here between the expansion of these binomials, the multiplication of these binomials, and the trinomial that results. So can anyone see, look at, this trinomial, that's the product, and look at the binomial and the terms inside the binomials. Can you see a pattern? Just take a moment to look at that. Are there any connections that you see at all between this and this? Anything? Don't be shy. Any connections at all? The x's in the binomials, and there's x's in the product. These are x's to the power of 1, and we have x to the power of 2 and x to the power of 1. Okay. Yeah, that's something good to notice. Anybody else? Yep. Okay. That's a good one. 2 plus 5 equals 7. Yeah. That's very important, actually. Anything else that you notice? 2 times 5 equals 10. Yes. That's what I wanted you to notice. That was the big important, two of the big important things I wanted you to notice. The connections, okay? So connections, how does one lead to the other? Okay, we identified the x's, which is good. But this fact right here, very, very important. Let's do a couple others real quick. A plus 2 and a minus 3. Okay, you should be very quick at expanding these now. This is a squared minus 3a plus 2a minus 6. That's a squared minus a minus 6. Let's see if those connections hold true for this one. 2 plus negative 3 is what? 2 plus negative 3 is negative 1. That's the same. And what's 2 times negative 3? 2 times negative 3 is negative 6. So what we're finding here is there's a connection between the expansion and the product of the binomials. So there's 2 terms in the binomials, and the 2 terms here that we're focusing on, that's the b value, right? Here's the b value, and here's the c value. So here's my question then. My question for you is, I'm going to take a little bit of a jump here. What are the 2 binomials? So I'm talking about, let's fill in these brackets here, that when you multiply this, gives you this. X squared plus 5x plus 6. So go ahead and take a minute and fill out the 2 binomials that give you that product. Okay, so you put x plus 2 in here, and you put x plus 3 in here. Anybody else have this arrangement? Okay, a number of you. Okay, can you tell me why you did that? because 2 plus 3 equals 5 and a positive 5. Very good. And 2 times 3 is positive 6. Good. That's very good, and that is correct. Good job. Now, the other thing I want you to notice is that because we have x's here, right, that's the variable that goes here and here. Okay? Don't put a and b or something like that. Or where do those go? Have to be the same variable. Okay? All right, let's get some more practice with something real simple. So what are the binomials that come from this one? Let's change the variable a bit. A squared plus 10x plus 21. This should come a little bit quicker for you now. Oh, yes, thank you. Thank you. That was a good enthusiastic hand. Good job. Okay, so it has to be a. Yeah, the variables have to agree. That's what I just set up here, right? So this is a squared and this is x. We might get into more difficult ones where you have two variables. I think we will get into that this chapter. But yes, in this case, that should be an a. Good. All right. What else? What goes in here now? What happens here? Anybody? Go ahead. A plus 7 and a plus 3. Okay. Anybody else have a plus 7 times a plus 3? All right. Let's just check that real quick. FOIL method. First, a squared. Now, I'm going to do the next two steps mentally in my head. That's 3a plus 7a gives me 10a. Very good. And then the last one is 7 times 3 is plus 21. So yeah, so do you see how the FOIL method and this whole adding the numbers and multiplying the numbers, you see how they all connect there? Okay. So yeah, so that's very good. Now, just a note, you could also have written a plus 3 times a plus 7. That is also correct, because the order doesn't matter when we're talking about multiplication, right? Because with any two numbers, like for example, 2 times 3 is the same as 3 times 2. That's called the commutative property of multiplication. Doesn't matter which way you go, back, forth, the multiplication is the same. All right? So it doesn't matter which one you wrote first here. Okay, we're going to get a little tougher here now. Are you ready for a tougher one? Am I going to add a negative? Well, maybe. We'll see. Okay, ready? So see if you can factor this. Let's do a different variable. So w squared, let's say plus 2w. Well, no, let's say plus 12w. Okay, w squared plus 12w plus 13. Okay, so this is not really that much tougher, but it's just sometimes students get messed up on this one. So see if you can factor this one. I'm going to freeze the screen and write the answers, then I'll show you in a few seconds here. Okay, how many of you had this for an answer? Okay, not very many. You have something else? Yeah, what, do you have something else? I should be minus? I should, okay. I want to show you that this is not the correct answer, okay? It was a bit of a trick. This is not the correct answer. Now why? Let's just talk about it. Why is it not the correct answer? Well, W times W is W squared. This is 1W plus 12W. That should give us 13W here. This is not 13, right? 12 times 1 is 12. So this is not the correct factored version for this. The tricky part about this is that students look at 12 and 13 and sometimes they forget, hey, I'm adding to this, multiplying to this, and they just go, hey, there's the answer. This is not the answer. I will tell you how to factor something like this. I don't think it's going to be in this course because we have to use a special formula. But right now you can say that, hey, you know what, there's no two integers that will work in these binomials. So right now you can just say this is prime. That means there's no factors for this one. Okay? Yes, sorry, it was a bit of a trick. But this one is prime. So you cannot factor it the way that I'm teaching you here today. Okay? So you'll need some extra information. Now, interesting, one of you said, that's very good, said that if this was negative, right? Is this the one you said was negative? Or this last one, negative? Did you say this negative here? Okay. So let's see. If this was changed, could we factor this? Could we factor this? Well, let's just see. I'm looking for two numbers that add up to 12. So add to positive 12 and multiply to negative 13. Now, when you come across this, if it's a little bit trickier to see, you can write the factors of negative 13. Do you remember doing this, factors of negative 13? There are only two options here, negative 1 and positive 13, or positive 1 and negative 13. Those are the only two sets of factors for negative 13. So in your process, and you may have to write down factors of this last number, what are the two? Which one of these would add up to positive 12? Which one? Yeah, the first one. So negative 1 plus 13, or 13 minus 1, is 12. So these are the numbers that add up to 12 and that multiply to negative 13. So we would do W minus 1 times W plus 13. So this one is factorable. Okay, those are the two factors. This one right now is, you can just say that's prime. Okay, it's not factorable. You can just say that for now. Okay, so is that good? Threw a little wrench in there. Tricky one. Okay, now let's get to, oh, this is the one I want to do. Something like this. Okay, so here's one with a negative sign in there. So again, what you want to do is factors of 35 that add up to negative 12. This one's a bit tricky. Go ahead and take a minute to see what you can do with this one. Okay, take a look at what I've done on the board there. Do you see a mistake there, or did you get this for an answer? What do you think about this? There are more factors of 35. Question? Okay, you have to consider the factors of 35, and there are lots of factors of 35. I just picked these two. Obviously, 5 times 7 is 35, but 5 times 7 is positive 35, but 5 plus 7 is positive 12. So when you see a negative in this part right here where it's supposed to be the sum, right, when you're adding, if you see a negative, you might have one or both of these numbers might be negative. So as you get more practice with this, you'll realize that, hey, this is positive. So positive comes when I multiply a positive and a positive, or a negative and a negative. So if you have a negative as a sum over here, it's like, can I add two positive numbers to get a negative answer? No. But you can add two negative numbers to get a negative answer. So you'll kind of realize that, hey, I've got a negative in here somewhere, so I have to consider some negative factors. All right? And then literally, if you just look at these pairs like this, and you say, yeah, guess what? This one checks out. Negative 5 plus negative 7 is negative 12. And negative times a negative is positive. So what you do then is you say the variable is z. Put z in the front. Then you literally just put this factor minus 5 and minus 7. And that should be your factored version. Now what you can do also is you can check, right? And how do you check? You just do the FOIL method. You multiply out. So that's z squared minus 7z minus 5z plus 35. That is z squared minus 12z plus 35. That's exactly what the original question was, so you've done it right. Okay? Does that help? And yeah, of course, here is your answer now. Oh. Okay, try this example. This is a bit of a different look, but yeah, see if you can factor this one. Notice that the terms are a bit out of order from what we've been seeing. Go ahead and give that a try. So, process is still the same, excuse me, except that these terms are out of order, right? So remember that the constant term here, you're looking for two numbers that multiply to get this. And the middle term, the b term here, the b constant, is the sum still. So I've listed some of the factors here for negative 18. And do you see how these factors right here, when you multiply them, you get negative 18. And when you add them, you get positive 7. See that? So the only thing is here now is that these terms are out of order. So guess what? The first terms in your binomials have to be, and this is just the way that you probably should look at it. There's two different things you could do. That I'll show you the first one. You can put the 9 and the negative 2 as the first terms here, just so you don't make a mistake. And then you can do positive a and positive a. That's one way you can write it. Okay? That's the one thing you can do. Now I'm going to just clean this up a little bit. At this point you may say, oh, I don't know if I like that. I don't know if I like that. That's a bit tricky. What you can do is this. If you see this polynomial, you can always rearrange the terms however you like. You can write the 7a first. You can go 7a plus a squared minus 18. You could do that. Or you could simply rearrange the terms as long as you keep the same signs. You could write it like this too. A squared plus 7a minus 18. So all of these are the same. And this one might be a little bit easier right now for you to factor. So you could just rearrange the terms, which doesn't change the polynomial at all. And then you could write your factors, and you could go a, oh, that's positive 9 and minus 2. And this would be correct. Notice that this factor right here and this factor right here, even though they look different, they are exactly the same. If you have a negative 2 and you add a, it's the same as having a minus 2. Okay? And of course, 9 plus a is the same as a plus 9. So either way is okay. They're both correct. I'm going to throw you a little bit of curveball here so that you can see different things, because you certainly will, get polynomials that are written this way, and you got to know what to do. You can either go ahead and factor them just as they are, or you can rearrange the terms. Okay. Okay, in this question here, this is not super tricky, and I know what you're thinking. You may be thinking, well, Mr. Maxwell, this is not really fair because in this section you told us that we were just going to focus on polynomials that look like this. You didn't say anything about another number here. We've only done, numbers that are 1. And that is true. And so this, I'm not, trying to really mess you up here. But what I want you to realize is that there is a greatest common factor to all the terms that you really should factor out first. Okay? So the first step is to look at all the terms, and you should do this every time you're asked to factor a trinomial or any polynomial. Look at each of the terms and see if you can factor out a GCF. And so what number is a common factor to each one of these terms? Negative 4. Is there a t in all of these? No. So just negative 4. Right? So what's left over? Well, negative 4t squared divided by negative 4 is just t squared. This is going to be negative 16 divided by negative 4 is positive 4t. Yep. Okay, good question. Why did I pull out a negative? You could pull out a positive 4 as well. The thing is, negative 4 is a factor of positive 28. The factor that will be remaining will be negative as well. Because remember, a negative times a negative gives you a positive. So let's just follow this on. Watch me in the last little bit here. What's 128? What is positive 128 divided by negative 4? What's that? 32. And it's negative 32. So do you see how negative 4 times negative 32 gives us positive 128, correct? Okay. Now, your question is valid. Why did I pull out a negative? Well, if you notice, and I'm just going to write this down here, minus 32, okay, to finish this off. If you notice, I pulled out a negative 4 because I want this coefficient here on this term to be a positive 1. If it's a negative 1, it makes it a bit trickier. So you want this to be a positive 1. So whatever, if this is negative, you should make it a negative as a greatest common factor. Okay, so I don't know, does that answer your question there? Do you see how I can divide a positive number by a negative number? No problem. The result is just another negative. So negative 4 times negative 32 is positive 128. Make sense? Okay, and I did that because I want this to be positive right here. Okay, good question. I'm glad you asked that, because if you are going along and thinking, well, I wouldn't do that, then there's a reason, why you should. It'll make your life easier down the road. So that's a good question. Now, when we get to this point, this negative 4 will always be a factor that we have to leave out front. You cannot just get rid of it. And I've seen students do this. Oh, I'll pull a negative 4 out and we'll chuck it. We'll throw it away. No, you can't do that. You have to show it as a factor, because it is part of this original polynomial. But do you see how I can now look at this trinomial right here, and you can factor it the way we've been just factoring the rest of the questions today? So that's what we do. So what two numbers multiply to negative 32 and add up to positive 4? Anybody got those numbers in their head? What? Negative 32. What are the factors of negative 32? Well, negative 2 and 16. Does that add up to 4? Nope. What else? 8, negative 4, maybe? That multiplies to negative 32, and what does that add to? 8 plus negative 4 is positive 4. So, there we go. We factored our binomial, found the two numbers that match up to these numbers, plus 8 minus 4. And this is your final factored expression. So another example from scratch here. You look at this trinomial. This is 1 right here. That's good. Now all we have to do is look at this term. It's positive 45. And this is what I like to do over here. Put the 45, write some factors out. Which factors are you looking at? The factors you're looking at, the factors here would be what? 1 and 45. Well, you take a look at those right there and you notice that 1 and 45, there's no way that's going to add up to 18, right? No way. So what are the other factors of 45? Well, 9 and 5, okay? Do 9 plus 5 in any way, positive, negative, whether they're both negative, anything, does that add up to 18? No. So those aren't the factors. What about 15 and 3? 15 times 3 is 45, and 15 plus 3 is 18. Okay? So do you see how these, the combination of these two factors right here, add up to the middle term? This should be an x right here. Add up to the middle term number, and they multiply to the constant term number. You see that? Yes? Yeah? You asked? Okay. All right. So then, now what we do is we say, okay, it's a trinomial. It comes from a product of two binomials. The variable is right here and right here. That's x. And the two numbers are 15 and 3. And are they positive or negative? They're both positive, so it's plus 15 plus 3. So we're taking the patterns that we've noticed when we expanded, and we're using those patterns to now factor, because that's the opposite of expanding. Okay?